Why does psychology need to be scientific? The reason why it's not a bad question is the following. Unlike a chemistry course, where if the professor asks about your intuitions about chemical bonds on day one, it's not a good question. I mean, unless you had a weird background and all your parents and grandparents were chemists, you don't really come into the course with a lot of intuitions about chemical bonds and electron shells. In psychology, you have a lot of intuitions, and a lot of them are probably quite good. If your friend you know well, it seems like something's bothering them, well, it's quite possible something's bothering them. If you think there's some psychological process in which they're trying not to tell you about the thing, but it's showing on their face, there probably is. There's a huge number of these intuitive psychology things that you've got right. A quick backstory is lots of stuff evolves. I'm going to do it briefly. We'll return to this. Humans evolved in physical and social settings. It, of course, would have been not too good for evolution for an individual to have no understanding of his or her fellow beings. So a bunch of capacities evolved. Some of them you take for granted: vision, color vision, three-dimensional space. Others, once you think about it, they obviously evolved some capacity for language. We have it, and some animal that anybody have an animal that runs by doesn't have that same capacity for language. It evolved. Even the capacity to think about other people is sort of right there. Like infants have an immediate understanding that one of those things is a chair and one of them is mom, and there's a built-in kind of expectation of human social interaction. So the intuitions are so good that it's possible that all this is a complete waste of time. We didn't need any scientific evidence. Any smart person who thinks about something will get it right intuitively. Sometimes that is true. There are psychology experiments where when you're done, you're wondering why they run that experiment. It has to work this way. And frankly, you're right. I'll try to skip those, but some of them are as obvious that you maybe didn't need to get the data. But, and I'll point out some definition of what to be scientific is. There are cases where people try really hard, are perfectly intelligent, and something goes kind of screwy, if I can say that on film. I guess that it probably gets by the censor. But with carefully done research, you can get your way out of the problem. This is partly a setup, as I'll say on the last slide, to the fact that the very next topic after Chapter 1 is not some interesting topic you're looking forward to. It's a chapter called Research Methods. The research methods are so critical here that you have to stick them up near the front of the course. We did everything we could to make the research methods chapter interesting. It's not that bad, but there has to be such a thing. One has to hesitate to say what be scientific means, because the activities that are science are extremely diverse and people do different things. You could just be crunching out formulas if you're a theoretical physicist, or walking around in a forest looking at plants if you're a botanist. However, sooner or later, there's some reliance on evidence that would override intuition. That's essentially the defining feature of science. So if you take a history of science class, that's essentially the turn intellectually centuries ago, is we don't care what it says in this famous document written by the king or whoever. We're going to test this out with evidence. And if the evidence comes out this way, we're going to tell the king he's wrong and get beheaded. So here's a case, a study, that's done in an instance in which somebody, not the author, somebody else will be up on screen in a moment, will probably sue when the film comes out, had certain intuitions. The study was done a while ago. I didn't happen to start with the singularly most recent study. I swear we'll have work more recent than 1998 in the course. The study was done, well, I said that. In 1998, yes, it says on your screen, psychic pet. What could be more interesting on day one than psychic pets? So, sorry for this small font, but we'll eventually have the guy on, or something on film in a moment. There's this guy in England, perfectly intelligent individual, thinks a lot about things. He thinks that maybe pets are psychic, and suggests in a book, a real book that somebody published, that maybe the public should carry out experiments to see if pets are psychic. And he got somebody, Pam Smart, and her dog, JT. The guy has a website. I think it's still up and running. Rupert Sheldrake, a biologist, an author. the world's most innovative biologist and writer, one of them. It's very innovative. And there's a picture about psychic dogs. So this guy gains some notoriety, enough that he gets an Austrian television company to go to the home of Pam Smart and do tests with her dog, JT. The family reports to Rupert Sheldrake this incredible phenomenon. Pam Smart, the secretary who lives 10 miles away from the home, lives in a home with, like, her parents. The parents report that at 5 o'clock, when Pam leaves her office, the dog, JT, goes to the window and waits. The office is 10 miles away. The only way, it's fascinating, it's a shame and things are going to fall apart, this story. The only way the dog could possibly go to the window and wait at 5 o'clock is if the dog has some psychic powers that maybe humans don't have, and the rest, everything's in quotes, of course, now. And that dogs evolved these psychic powers to understand humans over the course of dog evolution. Pam Smart, the parents, and Rupert Sheldrake really believe this. And so they get a film crew. There's the dog. That's cute, huh? You're supposed to say, oh, okay. They get a film crew, and, well, let's go to the darn film.